Okay, so this is the higher paper question 4. T, U, and V are 3 metal halide compounds. The ions of each compound were identified by observations from flame tests on the addition of silver nitrate solution. Okay, so we're looking for metals, which is telling us about flame tests. And halide is the silver nitrate test. Okay, so if you see that in a question, that's what we're talking about. Okay, so complete the table. So compound T gives an apple green flame test. Now, this is purely a knowledge question. You need to remember that apple green is characteristic of barium. Okay, so remember that much, and we can just double check using the table of ions, and we notice that barium is Ba2 plus because the question asks for the symbol of the ion. So that's Ba2 plus. Now, the same compound, when you add it to silver nitrate, has a chloride ion present. And again, this is a knowledge question. You need to remember that with silver nitrate, you get a white precipitate for chloride. Okay, a precipitate is where you get an insoluble chemical forming. It makes the solution go cloudy. Okay, so precipitate is a slightly different use than it is in geography. Okay, now the second question, we're told that this contains K plus. So we'll just double check in case we've forgotten that K plus is potassium. You need to remember there is no way to look this up in your exam that potassium produces a lilac flame. And it is important to use the word lilac instead of pink because the examiners are a bit fussy about that. And if you add silver nitrate to this solution, we discover that it forms a cream precipitate, and cream is associated with the bromide ion. Okay, and so again, if we just double check, look up the bromide ion, it's Br minus. So that's Br minus. And then finally, a brick red flame color is indicative of, tells us about the presence of calcium. And the calcium ion, we'll just double check from our table, is Ca2 plus. So there's Ca2 plus. And when you add silver nitrate to this compound, it produces a yellow precipitate, and yellow tells us that there is the iodide ion present. And you can probably work out that that's going to be I minus. Okay. Now, the next question, slightly difficult, more difficult. Suggests why a silver nitrate, that's a typing error, a silver nitrate test would not be able to distinguish clearly between halide ions which are present in a mixture of U and V. So if we have a look at U and V, with the silver nitrate, we get a cream precipitate and a yellow precipitate. And basically, if you've got a mixture of those two, you wouldn't be able to differentiate between the two. Okay, so the precipitates would mix, making it impossible to differentiate between the two. Okay, and then it says here, write an ionic equation. Okay, that's quite a key word out there. For the formation of the precipitate in the reaction between lithium chloride solution and silver nitrate solution. Now, because it's asking for an ionic equation, we really only want ions here. However, just to make it absolutely clear what's going on, we'll just write a quick word equation underneath. So lithium chloride reacts with silver nitrate. Now, we're seen in the question that we get these precipitates, and these precipitates are silver halide precipitates. Okay, so this is silver chloride, this is silver bromide, and this is silver iodide. Okay, so what that means is these two, the chloride and the nitrate anions or negative ions, swap over. So we end up with lithium nitrate, which is soluble and we don't see. Okay, and we end up with silver chloride, which is the white precipitate. Okay, so that's the white precipitate because it's chloride. Now, the question wants us to write an ionic equation for the production of this stuff here. Okay, so this is going to be in there, but this is an ionic equation, so we need to have a chemical formula. So if we look up the silver ion, we'll find that it's Ag plus. Okay, so we've got Ag plus, and that's going to react with the chloride ion. Okay, and we've met the chloride ion previously, so that's Cl minus. So consequently, these two are negatively, oppositely charged, but the same size charge. So that's silver chloride. But what we must remember is that this is a precipitate. This is visible. This comes out of solution, and consequently, we have to write a little s there because that means it's a solid. It comes out of solution, and we see it as a precipitate in the mixture, a white precipitate in this case. So the ionic equation is basically what we've just written here. So we've got Ag plus, in solution, when it's in silver nitrate solution, we need to put AQ in that tiny gap there. So I'm just going to write a new set of brackets because it won't fit. And Cl minus, okay, is also aqueous, is in solution. However, silver chloride, AgCl, is a solid. Okay, that's a solid, and we see that as a precipitate. Okay, so that was number 4.